Okay, we'll start. Good morning, everyone. Today we have with us Professor Kunj Joshi. Sir will be conducting few fun experiments with us today. Uh, Saukya, over to you, beta.
Yes, miss. Good morning, everybody, and my fellow science enthusiasts. Today we have with us Professor Kunj Joshi. He has taught umpteen number of students in a plethora of ways: one-to-one private coaching, conventional blackboards, projectors, and PowerPoint. Be it classroom or online lectures, he believes in experimentation, the cause and the outcome of curiosity. And he makes sure that he supports all his teaching with experimentations. From small tutoring centers to big coaching classes to seminars for the students of the entire 10th grade in a school, he has been there all. He believes that science is not something you learn, but something you discover. His only aim is to answer every why popping in each and every child's mind. And I'm sure he'd be able to answer yours too. Thank you. Over to you, sir.
Thank you for such a lovely introduction. Good morning, Aza ma'am, and all the students. I hope you are as excited as I am. So, let me ask you with a basic question. What is science according to you?
Um,
Yes. What is science according to you?
yes, Jenab, would you like to answer this?
Yes, miss. According to me and according to the writer of Homo sapiens, he says that science is a combination of three subjects: biology, chemistry, and physics. Bio
Very
is how
good.
humans came, chemistry is how they have evolved and how they are made, and physics is how they work.
Okay, that's a great textbook definition. Okay, really good at it. Uh, l- Let me tell you how I discovered science. Okay, and this is a human nature, right? We humans have always been very curious about it, curious about everything. Okay, just take an example. If you went to your friend's house and there is a big red button there which says do not press it, what is the first thing you will do? You'll go and press it,
You
right?
press it.
Why? Why? It says do not press it. What if it might kill you? But still you'll press it. ना देखते हैं ना क्या होता है. Let's see what
We
happens.
have a curiosity.
Exactly, and that is where science came from. When I was a child, no, I still remember my eighth grade. We had this topic called heat. Okay, and I was very curious, and my sir told that when you heat any substance, it expands, and when you cool it, it contracts. But I was not convinced. So what I did was I had this big yellow bulb in my bathroom. Okay, and it was glowing, and I knew that electricity produces heat, right? So I knew this bulb is very hot, which means the glass might expand a bit according to the theory which I have learned. So what can I do to make it contracted? What I did was I threw a pitchkari full of water on that bulb. Any idea what happened?
It
It
might
would
have
have burst.
exploded.
It exploded, right? And everybody in my house came to know that something happened. In fact, the neighbors came in. That day I learned two things. Number one, never take pitchkari in your bathroom. Number two, when you suddenly cool something, it does contract. And materials like glass, when they contract, they just break. Later, after 2 years, I came to know it was the gas present in that which exploded a lot. तब से पता चला कि नहीं, ग्लास को तुरंत ठंडा नहीं करना है. Okay, I had many questions. Okay, I still have many questions, and I only solve the questions by experimenting it and by failing in it, and then by succeeding in it. For me, failure is very important. Okay, I have tried a lot of experiments in my day-to-day life also, and with my students as well. And now it has become a habit that I try something, I fail in it, and then I redo it. Okay, I'll just tell you a few questions. Okay, just try to think about it. Firstly, uh, do you yawn? Do you guys yawn?
Yes.
Yes.
Obviously.
Is why is
Yeah.
yawning contagious? Is it contagious? Firstly,
Yes. Human.
Yes. Yes.
So why is it contagious?
It is contagious.
Why?
Humans.
Certain psychological reasons.
What
That's
is that psychological?
unsolved yet, right?
You're throwing your bad energy at others or in the environment.
I
Okay.
believe that is a mystical.
Yeah. Okay. Let me tell you scientifically, there is no such a theory that why is yawning contagious, but there are two or three major theories which are accepted overall. Okay. So just let me explain this. Yawning is a social thing. Okay. It starts from a center of your brain which makes you alert, and that is called as social mimicry. And human beings, being very social animals, we tend to copy a lot of things. I'll just give you an example. If you go to a certain country or if you go to a certain region of India where the accent of the people is different, you don't know, but you are actually copying their accent. That is a form of social mimicry. Okay, I'll give you one more example of this. Have you been to a birthday party?
Yes.
Yes.
Okay, let's imagine this is a birthday party and we are singing happy birthday to you, and the birthday boy or girl is cutting the cake and it's putting that first piece of cake into his sibling or his best friend's mouth. Everybody's mouth gets open, right? Does this happen?
Yeah.
Why is
Yes.
that so?
Yeah.
Do we try to copy
See,
it?
from my no, because from my perspective, it's because I feel I am his or her best friend, so I will open my mouth before he's coming to.
Okay, let me tell you, I have been to many parties where I was not at all a friend. Once I went to a birthday party by mistake, but still I opened my mouth. My point here is we tend to copy a lot, and this is imbibed in our brain so much, and it is imbibed in our evolution as well. Do you remember how do we talk to kids? We talk in their own language, right?
Yeah.
We blabber in front of, oh,
So
have you had food, mum, mum,
Yeah.
mum, mum. That makes no sense, but we still do it, right? Because we feel that that is that child's language and I need to copy it to connect with it properly. And that is one good reason for yawning, but still there is no clear scientific evidence why do we yawn. Okay, so there are many
Okay, then
questions. Oh, sorry.
you said that we yawn due to just mimicking others
Yeah,
because they are
that is
yawning.
one theory. That is a theory. See, there are
But then
three
why
different things in
we
science.
generally yawn when we are sleepy? Then what is the reason for that?
Okay, the first scientific reason of yawning is we take in more oxygen to make our brains calm. We feel
yes, when
sleepy at the time our brain needs rest, and our brain works best when it has cool air in it. And when we yawn, we take in extra oxygen to make our brain cooler. Okay, and that is relaxing. That is the basic biological reasoning of yawning. But what I was trying to explain is why yawning is contagious. You know that you can also yawn if your dog is yawning. It's not just related to human being. If your pet is yawning, you also yawn with them. Same thing happens with them. If you yawn, they will yawn. Okay.
It
Again,
also
as I
happens
told
with
you,
laughing. When one person laughs, the
yes,
other also
yes,
feel that
yes.
same feeling.
That is for laughing. Na, there is something called as herd thinking or herd. You can say when a group does
Herd
the same
mentality.
activity.
Herd
Okay.
mentality.
Not exactly herd mentality, but we all want a group to be in. Okay. Imagine if you are 3 a.m. or 3 p.m. at Dadar station during the night on the skywalk. Do you feel fear? Will you feel frightful? A hint of fear in you?
Who
Uh,
won?
You are all alone.
yeah,
more or less.
Yes, you will.
Yeah, obviously.
And imagine the same time, but now it's during Ganpati festival. And everybody of Lal Bagh and all the people, there are thousands of people on the streets and on the skywalk. You know none of them. But now will you feel secure?
Yes.
Yeah.
Technically speaking,
Yes.
now there is a chance because you are alone and maybe they are in a group, they can loot you, they can kill you, they can do anything they want. But now your brain tells you that you are safe right now because you have same species people in and around you. And that is called herd grouping, or there are many terms to it, but basically you must have seen when you watch a video at your home, you don't laugh that much if it is a comedy video. But when you are with in the room, or when you're with people you're watching with, you enjoy it more, because that is the time the smile combines and you create a laughter, a herd laughter, because you want to be a part of that group. Okay, this was my question about, this was just an introduction of how curiosity leads to scientific experiments. I'm not here to tell you about theories and hypotheses and experiment and about the laws. I'm here to teach you some basic experiments. Okay, let's go back to my childhood memory where I learned why I can't swim or float in Dead Sea. Do you know what Dead Sea is?
Yes.
The sea with the most salt.
Yeah, highest salinity content.
Highest salinity content, yes. Do you know that you can't sink in that sea?
Yeah.
Yes, it's too
Why?
dense.
Why?
The salt makes the sea denser than the human.
Yeah.
Very good. The salt makes the
makes it more and
sea
more
denser. What is density actually?
Density is the amount of
Amount
mass
of
per
matter.
volume.
Yeah,
Amount
mass
of
per
mass per volume.
Density is equal to mass per volume, right?
mass upon. Yeah,
Mass
Upon
upon
volume.
volume. So if the density is more, I won't be sinking in it, right?
Yes.
Yeah.
yes.
Yes.
Why is that?
Yes.
So let's look at the formula which we have here. Density is mass upon volume. The Dead
Yeah.
Sea has too much of that. The Dead Sea. Wait, just a second. The angle is different. Okay. Okay, I guess now you can see the mass. There is so much of salt in that small amount of water that it pushes you up. That is called buoyant force. The entire concept of sinking or swimming is how much weight or how much force you put on the liquid and how much force or how much weight the liquid puts upon you. Because there is too much of salt in small volume of water, the density is much more, and the reason it pushes you up and you can float in it. But again, I cannot swim in it. Why can't I swim in it? You can't swim in, you will just be afloat on the water. You can't swim, you can't sink. Why can't I swim? Any idea?
Because there is too much salt, so more density won't allow us to move around.
Yes, very good. Yes. Imagine it's like a thick liquid which you're trying to push it behind, but it is so dense that you cannot push it behind and you cannot swim forward. Okay. So when
Yeah.
I learned this first time, I am a very bad swimmer. Okay. I can't swim. I can act how to swim, but I cannot swim. So when I knew that Dead Sea, may you can't sink, I was the happiest. I can actually act that I know swimming and I can't sink, right? But I was still not convinced. So what I did, I tried to make my own Dead Sea. Obviously, I am not that some kind of hacker type YouTuber on YouTube will get those tons and tons of salt, put it in a bathtub and then try to swim in. I did it with a glass. I just have a glass here. Okay. Just a second, I'll bring my glass. Okay, so this is a normal glass. I hope you can see this. Okay. And imagine this lemon is us or me who cannot swim. I'll just fill the sea first.
Sir, are they supposed to do the experiment with you?
Yeah, yes, they can start doing it. Just take a glass of water.
Yeah. So guys, yeah, y'all can also get your apparatus and start doing.
So this is just a normal glass of water. Okay. Uh, I think top view will be better. Yeah. And this is me who cannot swim. Let's see. Yes, I cannot swim. It's synced in. Okay. This lemon is us. This is normal water, which has density 1 gram per centimeter cube. And it does not have that much of weight to pull the lemon up. Let's see what happens when we add salt to it. Okay. Before adding salt, we'll remove the lemon so that I can mix it properly. Okay. So this is our salt. As I told you, Dead Sea has high salt concentration. Almost 3 spoons of salt is enough. 3.5 or 3 full spoons. We'll try to mix it. Try to dissolve it as much as possible. If you have added too much salt or the water is too less, your solution might be saturated. So there will come a point where no more salt can be dissolved. That's okay, that's not an issue. We just want to learn how salt water affects buoyancy. Okay, now I have my salt water or Dead Sea in my glass ready. Let's sink in. Let's see what happens. It is floating.
Floats.
Yes, which means we have added enough amount of mass in the given volume that now it will have more buoyant force or more upward force, which will let me float on the Dead Sea, right? I'll just show you from the side view also. This looks like a lemonade, but it is just lemon and salt water. This experiment
can you repeat it?
Sorry?
I was disconnected.
Okay. What we did is we just added around 3 full spoons of salt in the water. We dissolved it and then we put lemon in it. The lemon, which was earlier sinking in, now floats up because we have increased the density of water so much. Imagine, see, let's just remove the lemon for a second. I have put almost 3 spoons of salt in it. Okay, it has now almost become saturated solution, but still the volume hasn't increased, but the mass has increased a lot. If the mass has increased, the volume has not increased. Density is the ratio of mass and volume. So here, density is the ratio of mass and volume, right? So I have density is equal to, what is happening? Yes. Mass upon volume. Okay. There is too much of mass, but the volume hasn't increased that much. So the overall value of density increases, and thus we can float on the surface of Dead Sea. Clear?
So my lemon was floating before I added the salt.
Oh, that might be reason. Maybe your lemon is big, or lemon has this openings on the surface of it. Lemon is a citrus fruit, and it has this openings on the surface of it. And if the pores are very big, it might float initially also. You can do the same activity with a potato or an egg. But the problem with potato or egg is then you can't use that much. But lemon, you can still use it, right? And I don't like wasting substances. The reason I told you lemon, if your lemon is big enough and if it is, you can say a bit old, okay, there will be the air spaces on the surface. If you look at the lemon surface very carefully, you will see those small openings. These openings contain air, and that will create buoyancy on its own. So there might be chances that your lemon, if it is big in size or the air cavities are more, it will float even before adding salt. So you can do the same thing with either an egg or with the potato. Yeah.
So what about the pin? What if I drop a pin into this water?
Pin, it depends how you drop it. Pin will still sink in water because the density is not still that much that it can keep afloat the small iron pin or steel pin. If I keep that pin on a aluminum foil on the flat surface, it might float. But if I put pin directly, it will definitely sink in.
Okay.
Sir, how much salt to add?
Add minimum 3 spoonsful of salt.
Sir, if I even add lemon, then will it float?
Lemon juice.
Yes, sir.
No, lemon juice will not make it float because lemon juice is a liquid. Okay, and I need salt because salt has mass and salt dissolves in water. So if you add, sorry, I'm not, Vihan, right?
Yes, sir.
Huh.
Sir, like if you put salt and lemon juice,
Then it won't be an issue. It will still float. Adding lemon or not adding lemon does not make that much of an difference to it. My point here is if you need to add something which dissolves completely, which will not increase the volume that much, but it will increase the mass to a greater extent. I need to change the density, right? I can change the density in 2 ways. Either I'll increase the mass or I'll decrease the volume, right? Okay, imagine this as numbers. So if this is 10, this is 2. तो या तो 2 को कम करो या तो 10 को बढ़ा दो if I want to increase the overall value of it. Clear?
Yes, sir.
Okay. I hope your lemons are now floating. Anybody else had an issue with lemons, that lemons were floating earlier also before adding the salt?
So I have a doubt.
Yes, sure.
Why did you say that the pin, it depends on you'll throw it, that it will sink or it will float?
See, if I throw the pin this way, it will have more surface area to interact with. And even if I throw it this way, I need to put an aluminum foil or some kind of sheet which will keep it uphold. If I throw it this way, it will definitely sink. To make my pin flow, I will either have to put aluminum foil and put a pin on this position, because now the interacting surface area will be more. Getting my point? More the area, less the pressure. What's the formula for pressure?
Perpendicular
Force
force
upon
upon area.
A perpendicular force upon area, right? Pressure is force upon area. I don't know if you can see the board or not. Pressure is equal to force upon area, right? So more the area, less will be the pressure.
Yes.
The reason I need to provide a larger area, the reason all the larger ships have a larger base to it, so that they have more area, so they apply less pressure and they don't sink in it. Clear?
And I had one question, that why does ice float in water? It's a very
Ice floats on water. Very good. Very good question. Ice has an anomalous behavior. Do you know about anomalous behavior?
Yes.
Yes.
What is that anomalous behavior?
from
When
0 to 4 degree.
2 degrees starts decreasing in density. Decreasing. No, wait.
Okay. This is very confusing, don't worry, because this thing is there in chemistry as well as physics. And both the subjects start the definition from a different point of view. So in chemistry, you learn from 0 to 4. In physics, you learn from 4 to 0. That is why the confusion occurs. I'll just try to explain you in the simplest manner. We have this one concept that I learned, okay, by bursting the bulbs of my bathroom, that heating increases the volume, right? When we heat a substance, its volume increases, and when you cool it, it contracts. The term anomalous means different or unique. Okay, so when I'm freezing water from 4 to 0 degree, from 4 to 0 degree, which means the temperature is decreasing. So ideally it should contract, right? Because my fundamental principle says when you heat, it expands, when you cool, it contracts. So from 4 to 0 degree, instead of contracting, it expands. And when ice is kept and when it is heated, or it is just kept outside room temperature, it will lose its heat. So it is heated from 0 to 4 degree. So from 0 to 4 degree, instead of expanding, it contracts. And from 4 to 0 degree, instead of contracting, it expands. So ice at 0 degree will have a density which is less than that of water, and so it floats.
Why
Also,
should it have a lesser density, even though it is growing in size? Maybe just by this much. I think the mass should have increased. It's like the particles coming closer together must have increased in a much higher way.
not exactly. Water, when you expand something or when you contract something, the mass does not change. Mass is an inherent
Yeah,
property. The
amount of
volume
matter
changes.
intended.
Yes, amount of matter remains the same, but the volume increases or decreases. The reason when I keep a bottle of water in fridge, when the entire bottle becomes ice, it expands, right? Which means the volume has increased. And if you actually
Yeah.
calculate how much amount of ice floats on water, it is just almost about 10 to 11% of ice that floats in it. And the entire 89 to 90% is still inside the water. Okay. So it cannot sink, but it will just remain about 10 to 11% above the water surface. Again, it depends upon what kind of water you use. If it is a sea water, there will be more amount of ice coming up because the density of sea water is higher, right?
And then why does water show such a property?
Sorry.
Why does water show such a property?
See, there there can't be reason for properties. Okay, you will have molecular reasons because water has hydrogen bonding. I don't know if you know this.
I
Hydrogen
know.
bonding is, yeah. So due to H and OH, H plus and OH minus properties, the bond angle changes. Due to the bond angle, the volume expands. The overall structure of ice increases in size when you contract it.
Okay, so
That
it's
is
mainly due to the bond angle changing.
not exactly bond angle changing. It is due to molecular bonding, but there won't be angle changing in the water molecule. See, this is one water molecule. There won't be change in angle between this water molecule. There still
Yeah,
will be O and H
H2O.
here. Yes, but the intermolecular attraction, that is attraction between one molecule and the other molecule
And
of water.
other.
Yes, that might
Yeah.
change because it is expanding. Clear?
Oh,
Sir, I added a little. You said if I throw a pin directly, it will sink.
Yeah.
So I had a piece of potato which was floating on the water, and I put the pin on top of it. And then
Pin
the
on.
pin started floating, and the potato fell to the bottom.
Okay, I didn't get you. What you did was, if this was your potato, you added pin here. Just a second. If this was your potato, you added a pin here, and then the potato sinked and the pin was floating, right?
Yes, sir. That's what happened.
Yeah, okay. That can also be due to surface tension of water. Do you know what is surface tension?
Yes,
That
it
is actually a
holds
very rare thing
it
if you
hold.
got the angle very right, it is very good, but it actually requires a lot of trial and error to get that perfect angle when you can actually float a pin. But I guess the pin will be in this state, right? In an horizontal manner.
Yes, it was in a horizontal. No,
Yeah,
it
yeah.
was like slightly
This way?
diagonal.
Yeah,
Yeah,
this way, right?
like
Yeah, still it will
yeah,
have more surface in contact with water, so it might float. But it's great that you got that angle, because it is difficult to make a pin float directly on water. Even if you
and
slightly
after
change
that,
it, it will sink immediately.
the potato always kept on sinking after that, and the pin also sank with the potato.
Does potato have any? Are we going to do any experiment with potato?
Yes, yes, yes. We are doing that experiment with potato. Don't worry. Okay. Potato will require more amount of salt to make it float up. As I told you, I use lemon because lemon also has this air cavities. So it does not completely sink. When you add lemon to it, it will just keep on touching the surface and it will rise up inside the level of water. So I don't need to put more salt or to create more density to make it float. I just had to add 3 tablespoons of salt and it did my work. Okay. Potato, you might have to add more and more salt to it to make it afloat. Clear? Any other doubts on this activity?
No, sir.
Okay, now let's talk about salt.
No, sir.
Let's talk about salt. Just imagine for a second, salt is NaNCl, right? Sodium and chloride come together to form salt, right? And we all know that individually sodium is dangerous, chlorine is poisonous, but when they combine, their properties totally change. And I was amused by this concept ki how come when two things chemically combine, their entire properties change. And salt is such an important ingredient to our food, right? Imagine your
We
food
can't.
without salt. Will you get any taste of food without salt?
Mm,
No.
can't.
Why is that so?
Salt enhances the taste of food.
Okay.
It's tasty.
Okay. What if I give somebody food which has no salt in it from the very start of his life?
You'll get
Will-
habituated to it.
Yeah,
Yeah,
he'll
Exactly, right?
get habitual. Yeah,
Which
exactly.
me- yes,
some will.
which means this salt is so natural to us that without this we cannot even sense the other taste. If I have very spicy food but I don't put salt in it, I can actually eat it because I won't feel that much of spice. This salt has many properties and this salt has been a part of our life, okay? And it is amazing to just think about it, how salt and water, this common ingredients. Imagine water. If you have any liquid on your hand, be it milk, be it honey, be it any kind of liquid, you feel that kuch hai haath mein, right? You feel that stickiness or soapiness, or you feel that that liquid is different. But do you feel the same about water?
No.
No.
Water is something else. The universal solve.
Yeah, we are so much used to water na कि ये तो अपना ही है. We literally use water in our everyday life for drinking, for bathing, for washing hands also. But if a small drop of milk is there on our hand, we still feel it sticky. कि कुछ तो है. By the time we don't wash it with water, we feel there is something irritating us. Water and salt are very important to us. And that is what our next activity is about. It is about osmosis. Do you know what osmosis is?
Yes.
What is osmosis?
When water goes from a level of higher concentration to lower concentration through a semi-permeable membrane.
Okay, is osmosis important?
Yes.
Okay, why is osmosis important?
Because without it, we won't be able to transport water and other nutrients to the cells that actually need them.
Okay, let's not be selfish and think about plants. Let's think about plants. Is salt or is osmosis important to them?
Yes.
How?
They
What
need
is
water
osmosis
for
as a first?
photosynthesis.
Okay, osmosis for some might not know. I'll just explain osmosis. Osmosis is movement of anything. Mostly it is solvent molecules from higher concentration to lower concentration. Wherever there is a solvent which has higher concentration on one part and the same solvent has low concentration on the other part, there is a tendency where this solvent molecules move from this area to this area. It is just how temperature flows. If I keep a cup of hot tea in room temperature, it will cool down. If
Even
I keep,
electricity does the same thing.
sorry,
Even electricity does the same thing. It tries to make the two
yes,
things
yes.
equal.
It makes it is like the entire this equilibrium concept. Now, it is very much similar to that uh, which was given by who was that villain of Marvel? What's its name?
Thanos.
Thanos.
Thank you. I knew the name. I was just acting. I was just making you excited. Thanos. He always believed in equilibrium, right? Everything should be equal.
Yeah.
Okay.
Perfectly
Similarly,
balanced as all
be it
things should be.
yes, be it temperature, be it electricity, be it water level, be it osmosis, there will be flow till the time both the constituents are equal or both the levels are equal. Okay. Imagine a plant. Okay, a normal coconut tree, not a plant, coconut tree, which is about almost 5 florid, 6 story height. Yes or no? Normal coconut tree.
Yes.
Yes.
Yeah.
Now tell
Yeah.
me, how come this coconut has water inside it when it is absorbing water from the ground floor?
Because the water is moving up.
Yeah, it
Yeah.
travels up the
Yes,
plant
exactly.
Xylem.
How
and
does it?
enters the
Yes, exactly. How does it move
through
upwards?
the xylem tissue.
How
Through
does it move
xylem
upwards?
tissue.
It
Xylem
is
tissue.
absorbed.
Capillary action.
Very good.
Or
Capillary action. And is osmosis important there?
Yes, to absorb the water from the root here.
Exactly. The first stage will be absorbing the water from the outside atmosphere, outside environment of the soil. So what it does to absorb it, it creates more solute concentration inside it. So
Tap.
imagine I am the root. Okay, I am the root and the xylem part. I will store much of sugar and salt in it, and outside me in this soil there is water. So inside me there is less water concentration, and outside there is more water concentration. So by the principle of osmosis, water will move from outside environment to the inside environment. That is how it will collect all the water, and then through a capillary action and transpiration pull, it will go upwards. And that is such a beautiful mechanism, right? Imagine this plant which cannot even move without any external energy. Okay, I stay in a building on fourth floor or fifth floor or sixth floor. For me to get my water, my watchman needs to start the motor so that he can pull the water upwards, and then the water comes down due to gravity. But this coconut tree or any tree does not have this watchman wala system. Okay, so osmosis is very important for them, and that is our next activity. I'll just tell you what you need to do. As I told you, you should have 3 potatoes, uh, two
Yes.
peeled potato and one boiled potato. Okay.
So
Slightly by maybe with the help of spoon or maybe with the help of knife, you can just cut this edges. Okay, make sure you make a cavity in it. Okay, this is how you need to do it. This is the boiled potato. Make a cavity in it. Normal potato. Make small boats of potato and keep the boiled one in between.
So after that,
just a second. Just make cavities in it.
done so.
Yeah. So this potato is peeled. This is my potato 1. This is peeled plus boiled, and this is peeled plus salted potato. Oh, peeled and I'll add salt in it. Just make these cavities. Take our ingredients, salt in it. Listen to me carefully. Add salt in the cavity of boiled potato and 1 raw potato. You won't add salt to all the 3 potatoes. Is this clear? Add salt to 1 boiled
Sir, can you
potato.
please repeat it?
Yeah, I'll repeat it. Take 3 potatoes, okay? Boiled potato in the middle, 1 raw potato here on the both the sides. Make cavity in it, this kind of cavity in it, okay, in all the 3 potatoes. And now you will add salt in it. Salt in which potato? Potato number 2 and potato number 3. This potato I won't add anything. Make sure salt does not fall in your plate. If little bit it falls, it's okay.
Yes, sir.
So you have added only salt, right?
Yeah, only salt. Only
So
salt.
we need to add 1 tablespoon salt.
Depends upon your cavity. If your cavity is greater, you can add more salt. I can add only, I guess, 1 spoon of salt. That's it.
So
Once
can
you,
you please tell me when I was disconnected?
okay, ma'am. What we did is we took 3 potatoes, okay, and we made cavities in them. Okay, 1 was boiled potato and 2 were raw potatoes. I made a cavity inside them. Make sure the cavity is not through and through. You need to make a cavity, not an entire opening. Tunnel nahi banana. Okay, you'll make a cavity, and in 2 potatoes, that is 1 boiled potato and 1 raw potato, I'll add salt in it. Amount of salt might change depending upon your potato and cavity, but make sure it is entirely filled with the salt. Now,
Sir, we have to make that square shaped or circle shape.
any shape is okay. Any shape is okay. But make sure it should hold at least half a spoon of salt, so that this experiment, okay. Then what you will do is you will just add water to the tray. I repeat, to the tray, not inside the potato, to the tray. Slowly, you will pour water. Make sure you don't sink them. Visarjan nahi karna hai hame potato ka, okay? You just have to dip them halfway through. Vihan done?
Sir, what is going to be the result of this?
Let's see. This result, we'll see how much it happens in 10 or 20 minutes. But I will suggest you keep this for at least 1 or 2 hours, okay, aside, and then you'll observe what results we will have. Just let everybody finish, and then we'll discuss what results we are expecting, and let's see whether it matches or not.
Sir, could you repeat? My audio is not working.
Okay. We took 3 potatoes. Okay. One potato was boiled, and the two were just peeled raw potatoes. We made cavity in them, and then I added salt in 2 potatoes, one boiled potato and one raw potato. I put them in a tray, and I add water in the tray. Water should be almost covering the half of potato. Don't just overflow the entire plate. Make sure your water is not touching the salt inside it. इतना ज़्यादा पानी नहीं भरना है हमें. We'll just fill half till the potatoes are sinking half. Okay, and then we'll wait for osmosis to happen. Okay, sorry.
The salt has already started becoming like wettish.
Which salt? Can you show me on screen, please? Which potato?
Yes,
Sorry.
Okay, guys, can you all show us what I have done? Yeah. 1 second.
Yes,
I can't show miss because I am on my PC. I can't show.
Yes, I can see Ghanshyam's setup, Anaya's setup, yeah, Suhana. Very nice. Yes, Pragun, what were you saying?
Ma'am, actually, I'm on a iPad, so I won't be able to show.
Okay. It's okay.
But the salt inside my the boiled potato has started becoming
boiled potato. If it has started becoming boiled potato has started becoming wet.
Yeah, the one in the boiled potato.
Okay, was your potato dried before using this, or it was just newly boiled?
No, I'm very sure it was completely dry.
Okay, so don't worry, just wait for it. I'll tell you what the results we are expecting and what we'll get. The setup is done, right?
Yeah.
Okay, now listen to me carefully. This potato right here, this boiled potato, will have a bit of water because this salt absorbs water from the cells of the potato. Because we have boiled it, okay, the cells of potato will have some kind of water, and this salt will take away all that water. But this potato, the potato which is peeled and not boiled, this potato will absorb all the water from the tray because water concentration is less inside this and more here. So maybe after half an hour, this entire salt will become a solution, whereas this salt will just become, you can say, clogged up solid, because this will absorb water only from the cells surrounding it. It won't absorb water from this water. Can anybody tell me why?
Because cells also have water in it, in the vacuole.
Okay.
Yeah.
Okay. Can you try to tell me from the point of view of osmosis?
So when we cook the
The
potato,
boiling point is, I think it is at higher concentration, the boiling point of the potato. It is hot and the water is cold. So the cold water won't move towards the hotter water.
No. I need from the point of view of water molecules and not temperature.
so when we cook the potato, that time the cells lose their water, so they don't have the.
Okay. Somewhere near it. Anybody else?
Sir, probably like for example, the salt is more concentrated and the water is towards salt.
Yes, water moves towards salt. But what I'm telling is, why did I take this boiled potato then?
Oh, sir, we have studied that due to the process of osmosis, salt absorbs water from its surroundings.
Yes, it absorbs water from its surrounding. But why did I take the boiled potato then?
Because boiled potato would have water.
No. I'll tell you, after 30 minutes, this potato, which is not boiled, will take away all the water from the surrounding, but this won't take all the water. This salt will take water only from the potato and not from the outside external environment. Why?
Because the not boiled potato has no water content in it.
But so it will absorb from the outside surrounding.
Yes.
Okay. Not really.
No, I think my answer is wrong.
Okay.
So, can I say?
Yeah, sure.
So I'm just guessing, but since we have boiled a potato, due to the heat, the cells might have died.
Okay,
and the
very
cell
good.
membranes and all might have broken down, and only the water is left inside.
Okay. Your first half of the answer was perfect. High five for that. All the cells are died here. So this salt will only absorb water from the potato and not from the grain. Because osmosis के definition में एक और चीज है जो हम सब ने ignore किया. That is semi-permeable membrane. And a dead potato will not have semi-permeable membrane, so the water, it cannot pull water from the external environment, sorry. But this potato right here will pull the water from the external environment.
Because its membrane might be died, that's why.
Exactly. The reason I took boiled potato, because this boiled potato has dead cells. And salt will only take the water from the cells which are surrounding the cavity. It will not pull water from the external environment. Whereas this potato out here.
And in the not boiled potato, it can absorb the water from the surroundings because it has a semi-permeable
membrane. Very good. So it
I
is
have a question. The one which I have
semi-permeable membrane.
Just a second. I was
have
listening to one question. Yeah.
So in the field one where I have to put the salt, so I put the salt, and now what has happened is the salt inside has become moist before the boiled potato.
Yes, that is what we are going to find. That is what I'm trying to say. This potato will become a solution, not this potato.
That already, yeah.
This potato, which
so
means
it has already started to get moist.
Yes, that is what I need to explain you, that this acts as a root. This roots will store so much of salt that it absorbs water from the external environment. I've put boiled potato just to show you that the dead cells will not be able to do the same process. And why I've taken this potato, because this has no salt, so there won't be any water here. If you touch it, there is nothing here because it has no salt. So the concentration or the water level inside the potato and in the tray is more or less the same. So there is no point of absorbing water from the external environment. This potato, after maybe
so why when the cells die, actually
when the cells die, they won't have that semi-permeable membrane. They will just have cell wall. Okay, and then osmosis won't happen.
There should be a medium of the membrane.
Yes, there should be a semi-permeable membrane for osmosis to occur. Okay. If you see this salt has started absorbing water. Okay, this has slightly become paste kind of consistency. This has just absorbed water from the surrounding boiled potato. Sorry?
Yeah, I wanted to say that my first potato has completely absorbed the salt.
First potato as in kacha and peeled potato.
The peeled one, only the peeled one, yes.
This one, without salt?
No, the first one, the peeled one with salt.
Yes, that is the result we are expecting. That is how it should be. Just keep it for around more 20 minutes. You will see a solution here. And that is how plants absorb water. They keep a high concentration of solutes in them so that the water is absorbed due to osmosis. Anybody else got the same results or any different results?
Yes, sir. Even my peeled potato with salt, the salt has started to turn into a paste, like it is absorbing liquid.
Which means it is absorbing water from the surrounding. But the boiled potato won't absorb that much of water because it will just absorb water from the cavity cells. That's it. It cannot pull water from the tray.
Yes, sir. The boiled potato, the salt is relatively unchanged.
Yes, that is what we are expecting because the cells are dead, no semi-permeable membrane, so no osmosis. Is this clear?
Yes, sir.
And now try to apply this principle of adding salt to substances to pull out water. That is how pickles are made. We add salt to it so that the entire water is pulled out and my substance which I am pickling that stays for a longer period of time.
Yeah.
Clear?
So that's why we don't add salt at the beginning, like to food, so it doesn't like secrete water.
Yes, but for some substance we need to add salt to remove out all the liquid from it. Depends upon what food are you preparing.
So the
Yes.
first potato, the one, the unboiled one which we peeled and did not put salt in it,
Yes.
will the cavity in it fill up with water in some time?
No, not at all, because the concentration inside the cells of potato and in the tray is more or less the same. So it won't pull that much of water.
Okay, sir.
This is our control. Just to show that if there is no salt, there won't be water absorbed. This is to show that dead cells cannot perform osmosis, and this is to represent osmosis. Clear?
Sorry, sir, the middle one is for what?
The middle one is to explain that dead cells cannot perform osmosis.
Sir, the middle one is absorbing and the middle salt is very soggy.
The boiled potato.
Yes.
Yeah, boiled potato will absorb some salt from the just the layer of the cavity. That's it. It will become soggy, but it won't become a paste. Whereas this in sometimes will become a paste and then a saturated solution.
So only this peeled potato is becoming a salt, and the middle one, that is the boiled potato, it's getting wet, but it's not like in a salt, in a paste consistency as the peeled one.
Yes, and this won't change much also because this will absorb all the water which is there in the surrounding cells only. Whereas this will pull away all the water from the. Yes.
I have another club now, so can I join that?
Yeah, sure.
Yeah, I guess we are done with our experiments, no?
Yes, exactly. We are done with our experiment. Just one small ending note. Just keep this tray for almost 30 minutes more to observe better results. Okay. Yeah, that's.
Okay, so.
Tanish, would you?
Yes. On behalf of all the students, teachers, and every member of our science club, I would like to thank Professor Kun Joshi for enlightening us and teaching us all something new. It has been an honor to have you among us, sir, and a joy to conduct these engaging and fun experiments that you have shown. Thank you once again for imparting your knowledge and delivering this wonderful seminar. I hope you enjoyed your time with us.
Yeah, I surely enjoyed it, and I am very glad that I got a chance to interact with you guys. Thank you, Aiza ma'am, for inviting me, and it was great interacting with such curious minds. It reminds me of my childhood, but just don't break bulbs, okay?
Yeah. Thank you.
Thank you so much, sir.
Thank you,
Thank
sir.
you all. Thank you.
Thank you, sir.
Thank you.
Sir, bye, sir.
Bye.
Bye,
Thank you,
sir.
sir. Bye.
Thank you.
Bye, sir.
Bye.
Thank you. Bye, ma'am. Bye, sir. Thank you.
Bye.
Bye, sir. Thank you, sir.
Thank
Have a
you.
nice day.
Bye, sir. Have a nice day, sir. Bye.
Bye.